Greetings of the day. This is your Anira, faculty and students from VIP classes. Okay, students. Yeah, today we'll talk about Coulomb's law in vector form. Say I have two charges Q1 and Q2. Okay. So if I take both charges like positive, positive, if I take, what happens here now? This positive, no? So both are positive. What happens here? This positive will repel this side, this positive will repel this side. So if I say this is first charge, this is second charge. So force on 1 because of 2 will be like this, and force on 2 because of 1 will be like this. That's what I have shown in the diagram. Some separation is R. See students, here this particular scientist Coulomb, so he found the force not by knowing the charges. What he did, like for example, you have a identical sphere. One sphere is there having charge Q. When he brought in contact with another identical neutral sphere, the particular charge Q of the first sphere will be shared identically. It becomes now Q by 2, Q by 2. Again that Q by 2 charge sphere, if it is brought in contact with another neutral sphere, charge becomes Q by 4, Q by 4. So for a given distance, he made charges like that, and then he found the value of force. And then he fixed the value of the charges. He made distance R, 2R, 3R, or R by 2, R by 4, R by like that, 6, like that, okay? Then he found the relation. So he said that the force of attraction or repulsion between like charges, if they are like charges, repulsion. Opposite charges, attraction, is proportional to product of the charges and is inversely proportional to square of the distance. So from that we can write F is equal to Q1 Q2 by R square, and the value of proportionality constant we call K, and the value of K is here given by 1 by 4 pi epsilon naught, whose value how much beta here? 9 into 10 power 9. And I wrote the units here, Newton meter square by Coulomb square. How it has come? In this formula, write this 1 by 4 pi epsilon subject. Then Newton into meter square, Newton meter square, by this charge will come left side, Coulomb square. And here epsilon naught is called permittivity of the free space. Okay, what is permittivity? It is the ability of that particular medium to allow electric field lines to pass through it. So we are taking here epsilon naught as permittivity of the free space. Okay, so what is that ability of the particular free space to allow field to pass through it? That is this measure. Okay, and next we write vector form here like this is Coulomb's line, normal expression. And then let us take Q1 and Q2 are two charges with position vectors R1 and R2. Force on 2 because of 2 because of 1 will be like this. Force on 1 because of 2 will be like this. If I ask, okay, Q1, where is Q2? So you will show that this is the direction R21. If I ask Q2, what direction of Q1? Position of Q1, this is like this you will say. And you know, for mentioning the direction of the force, we take unit vector along the position vector. So now, if I ask force on 2 because of 1, that is given by 1 by 4 pi epsilon naught, force on 2, no, Q1, Q2 by position of 2, R21 square into R21 cap. Okay. Similarly, force on 1 because of 2 is given by 1 by 4 pi epsilon naught, Q1, Q2 by position of 1 from 2, how much? R12. So R12 square, direction in the direction, R12 cap. And you can write A cap is like A bar by mod A. So R21 I can write R21 bar by mod R21. So like this, so this becomes R21 cube. Similarly, you can write of F12 also. Right, this is what Coulomb's law in vector form, and this Coulomb's law, keep in mind, applicable for point charges. If charges are not point, what happens? So we use the technique of what? Integration by dividing a particular distribution of charge, either linear or surface or volumetric distribution. We take small elements and then we extend the concept that we see in next video. Okay, now a simple numerical. For example, an electron is revolving around the nucleus. Okay, so we write the force on electron in terms of vector form. So let's say nucleus charge is JE, electron charge here minus E. So force on electron because of this particular nucleus, how it will be? It will be in this way. And position of electron is in this way. Force on is in this way. So force and position vector are opposite. So magnitude of force now K, Q1, Q2 by R square. Direction how it is? Opposite to R cap direction. Force is opposite. Position vector is rightward. So minus R cap. So you can write K Z E square by R square. And R cap you can write R bar by mod R. Okay, so this R and R square become R cube. So like this you can write the force on the electron, okay, in vector form. But following, sometimes they may ask, say one more numericals kind of thing we'll take. For example, so two charges are given with position vectors. Say for example, one charge is at 1, 2, another charge is at some 2, 3. Okay, so having each value of charge same Q1 is equal, Q2 is equal some 10 microcoulomb. Find the force of interaction between them. So what you can do now here, so you can write this vector diagram like this. So Q1 charge, its position vector is R1. So how much given R1 here, you can write down. So 2 comma 1 point in this plane. So you can write I cap plus 2j cap, and you can write R2 bar. How you can write 2I plus 3j cap. Now R1. So now Q2 charge, it is position vector of R2 2 comma 3 point. Okay, this is R2 bar. So this is a line joining them. So if I take both charges are plus plus, isn't it? So force on this 2 because of 1 will be like this. Force on 1 because of 2 will be like this. And position vector of 2 from 1 is this one, R21 bar. Position of vector of 1 from this 2 is R12 bar is like this. So if I calculate force on 2 because of 1, you can write down 1 by 4 pi epsilon naught, Q1 Q2 by position of 2 from 1, R21 square, direction is R21 cap. Now first of all, you find from triangular law this value how much. This is R1, this is what beta, R21, and this is what, R2 bar. Right, triangular law, R1 bar plus R21 bar is equal to R2 bar. So R21 bar will be R2 bar minus R1 bar. So position of 2 from 1, R2 1, R2 minus R1. R2 how much? 2I plus 3j minus R1. R1 we took 1 comma 2, right? Yeah, I plus 2j. You're following? So you can write now R2 1 bar will be I cap plus j cap. And what is magnitude beta? Under root of 1 square plus 1 square. How much this is? No, you see here. So R2 1 bar is root of 1 square plus root 2. So now how much value of force will be? K. K value how much? 9 into 10 power 9. Q1 Q2 10 into 10 power minus 6. 10 into 10 power minus 6. Q1 Q2. R square is root 2 whole square is 2. Simplify. This becomes 9 into 10 power 9 into 10 power minus 5 and 10 power minus 5. 10 power minus 10 divided by 2. This becomes 9 into 10 power minus 1 by 2, which becomes 4.5 into 10 power minus 1 Newton, which becomes 0.45 Newton. Okay, and direction how? This is the magnitude of the force. Direction will be radially outward. Okay, here like this we can apply what? Coulomb's law and its vector form, a small application. Okay, yeah, thank you all. So please do subscribe and share my channel. Thank you all.